Hello all, today we're starting a new geometry lesson 7.1 Dilations. Our learning objectives: draw dilations and draw dilations in the coordinate plane. First of all, let's look at the definition of a dilation. A dilation is a similarity transformation that enlarges or reduces a figure proportionally. Dilations are completed with respect to a center point and a scale factor. So basically, it's shrinking or stretching an image or a figure without changing the angles. You're just, changing the sides proportionally. Okay, so the figure stays, similar to the old figure. Okay, now let's do some examples. First of all, when you do a dilation, you need a figure, you need a scale factor, and you need a center. Okay, so for example, exercise 1a, copy the figure and point J, then use a ruler to draw the image of the figure under a dilation with center J and the scale factor K. Let's do this. So let's say this is our center, and this is the figure. First of all, you draw rays from the center to each vertex of the figure. So for example, if this is the center J and this is A, B, C, and D. So from point J, you draw a ray that passes through point A, and then from point J you draw another ray that passes through point B, and then another one that passes through point D, and then another one that passes through point C. Okay, and then you locate a point on each ray whereby JA equals, or JA prime, which is the new point, equals 3 over 2 JA, and JB prime equals 3 over 2 JB, and JC prime equals 3 over 2 JC, and JD prime equals 3 over 2 JD. 3 over 2 is 1.5. So from J, this is almost 1.5 of JA. So JA prime equals 1.5 of JA. Same thing with JB. 1.5 is almost here. And then JC, 1.5 of JC, somewhere close to here, for example, and JD, 1.5 of JD, almost here. Okay, so this will be D prime, and then you connect the new points: A prime, B prime, C prime, and D prime. D prime. Okay, something like this. So as we can see, this is the new image. Okay, and it's stretched image of the old image. Okay, because K, which is the scale factor, equals 3 over 2, which is greater than 1, it will be a stretch. Okay, if K is less than 1, it will be shrink, as we're going to see in the next example. Alright, please pause the video at any time and try to repeat what we've just done to make sure you understand it. Alright, let's look at the second example. We have triangle J let's call this MN, for example. Okay. Now the scale factor K equals 0.75, which is less than 1. So the new image or the dilated image will be shrink. We're going to shrink the existing image. Alright? Not stretch. So we draw a ray from the center, which is J. Now the center happens to be one of the vertices. Okay? So when you draw rays from J to M and another ray from J to N. Okay? Now, the new image will be a shrinking of the old image by a factor of 0.75. So Jm prime equals 0.75 Jm, and Jn prime equals 0.75 of Jn. 0.75 is 3/4, so let's say it's almost right here, and then same thing right here. Okay, and then so this is M prime, this is N prime, and then we connect M prime to N prime, and this is now J prime stays the same as J because the center is the same as the vertex. So our new image is dilated image is J prime, M prime, N prime, which is right here. As you can see, it's a similar triangle to JMN, but a smaller copy of it. I hope you get the idea. Pause the video and try to do this yourself. We're going to do more examples. Alright, let's look at these two examples. We want to draw dilated image of segment AB with center S. So again, we're going to draw rays from center S to points AB. This time we're dealing with just a segment, not a triangle or rectangle or anything like that. Okay, so let's draw a ray from point S to point A and another ray from point S to point B. Okay, now the factor right here is 2, which means that S A prime equals 2 S A and S B prime equals 2 S B. So it's twice the size. So if this is SA, SB prime is somewhere over here, SA prime. And SB prime is, or P prime is somewhere over here. So now we connect both points, and this will be our dilated image. Okay, now let's look at this example. The dilating factor is 1/2, which means that the new image will be smaller than the existing image. We're going to shrink the existing image. So let's draw rays from point S to each vertex of the triangle. Alright, now the scaling factor is 1/2, so SR will be, or SR prime will be half SR, SC prime equals half SC, ST prime equals half ST. Alright, so the points that we're looking for, this is R prime, C prime half the distance from S to C, somewhere over here, and T prime is half the distance from S to T. And then we connect the dots. And as you can see, these two triangles are similar, okay? Their size is different, but they are similar. The angles are the same, but the sides are, proportionally smaller. Alright, I hope you get the idea. Pause the video at any time. Alright, our last example is determine whether the dilation from figure Q to Q prime is an enlargement or stretch, or a reduction or shrink. Then find the scale factor of the dilation index. Pause the video and try to answer that. So, as you can see, the new image, which is this, is an enlargement, okay? So the answer is enlargement, because it's larger than the original image. Of course, the new image is the one that has the points with prime, like Q prime, A prime, B prime, okay? Original image will not have prime in the names of vertices, okay? Prime is this, when you say Q prime, you call that Q prime, okay? So we know it's an enlargement, we just need to find the factor, the scaling factor. Alright, so let's take, we know that CQ prime is always K, which is the scaling factor, times CQ. As you can see, CQ prime equals 15, equals K times CQ, which is, it's given as 5. That means divide by 5, divide by 5, that means K equals 15 over 5, which is 3, which means, the dilated image is 3 times as bigger as the original image. In fact, the sides are 3 times as bigger, okay? So I hope you understand, or you know how to find the scaling factor, okay? You choose one of the sides, you write the formula, and then you find K. Should be straightforward. Alright, we're going to do more examples in our session today. Alright, stay safe and see you next time. Bye.